Good morning, everyone. This is OU. Hello, and welcome to my podcast, Most Significant Bit, where we explore the connection between engineering, technology, humanities, and the arts. I am OU, and today we are discussing the application of water collecting beetles. One example of a biomimicry that we will be focusing on today is water collecting beetles. And this is inspiring fog harvesting in the desert. So this is a very popular discovery. We will briefly talk about the discovery of this, the history behind it, and the main impacts of this discovery on science and on us. And also we will discuss the applications of water collecting beetles in different industries, different stakeholders, and different target audience. And lastly, we will make a conclusion on the positive and negative impacts of water collecting beetles on us. So that is the structure of our podcast today. And obviously, we will talk about the feasibility and the future of these applications. So, when was this water collecting beetles discovered? Only a decade ago, it has been discovered in the Namib Desert that the beetles there harvest moisture from the air to survive. So how do they do this? They do this by condensing fog in its hardened shell that contain tiny bumps, and then it channels the water droplets to its mouth. So the condensation is the process of moist air coming into contact with a cold and dry surface, which is happening here, and flowing down the surface and collected. From here, there are multiple applications that can be applied by this discovery. The first one is that inspired by this nature's phenomenon, MIT researchers replicated this structure with glass and plastic and were able to build a structure that harvests fog in the desert for people residing there. This is a huge discovery for a lot of refugee camps and tents, generally in remote areas that lack access to surface water, which means that they could gather fresh water now. The second application is that it is also affecting power plants and industrial facilities as they're working towards more efficient evaporating cooling designs that reduce water consumption. So this has a huge environmental factor to this. The third application would be that residents in dry areas like the edge of Sahara Desert in Morocco have been harvesting fog for years. Their current method is using mesh to route the water into pipes, which transport it back to the village. And so from that method to this fog collecting method would be much more convenient and easier for the residents in the Sahara Desert. Another application for the new material include harvesting water, making a lab on a chip, and creating microfluidic devices and cooling devices. And the last but not least industrial application we've been seeing so far is that US military has shown interest in using the material from the beetle as self-decontaminating surface that could channel and collect harmful substances. What this means is that when there's a substance that's harmful on the surface that replicates the surface skin of the shell of the beetle, it doesn't absorb it and it just reflects it back. And so harmful substance wouldn't be absorbed by this material that's being replicated. And that is a huge discovery because this could be used for clothes, armor, any kind of military weapons. And so this is a huge discovery. From when this was first discovered, scientists were able to use 3D printing technology and investigated the curvature structure on the surface, and they are being able to optimize the design of this three-dimensional convex curvature of the back of the beetle. And so far, this research is still ongoing, so it's hard for us to make conclusions. But from what we know so far, there is more positive impacts compared to the negative impacts by discovering this. There isn't the big negative cost to continue on researching this, as this is not harmful for the beetles, not harmful for the nature. We are just replicating what we're seeing from the water collecting beetles. And so this is a huge environmentally positive discovery. And the only negatives we can see so far is the cost of the research, as this is a quite pricey research to invest in, but there's no direct impact of it on us or nature. So to conclude this scientific podcast, we will summarize all the points we talked about so far. We discovered about the Namib desert beetle that collects water by condensing fog in its hardened shell and channel it to its mouth. By discovering this, we have started to replicate the back of the beetle's bump, and we are trying to make a similar material that instead of absorbing water or any kind of solution, it deflects it back. And by doing that, we are able to make change on multiple industries, such as the defense industry, using it for cooling devices and microfluidic devices, also using it to help with residents that are living in dry areas or people living in refugee camps where they can't access fresh water. And lastly, it's impacting how power plants are designing their cooling systems. And I will end this podcast with an open-ended question, and it would be that if we were to make a very giant design that replicates exactly like the water collecting beetle's back, how long would it take to collect a lot of water? I am very curious because obviously we don't have a beetle that's bigger, that's the size of us, or that's the size of a building. So I do want to see a design that is very, very humongous and see how long it takes for that big humongous design to collect water. I feel like that would be a very good experiment. And I am curious what my listeners' thoughts are on that design. Thank you, and you were with OU.